Okay, so in this lecture, we're going to continue our discussion about the row with maximum ones problem. So let's write that down. Row with max ones. And if you are new and you don't know what this video series is about, this is a video series about programming interview questions. And so the previous two videos looked at this problem using more inefficient solutions. And this video will look at the most efficient solution. So if this is the first video you're watching, you probably want to watch the first two first. Okay, so just to review the problem once again, we're given a matrix as input. So something like 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 1. Okay, so the important feature of this is that the rows are sorted. Okay, so the zeros are always to the left of the ones. And so in this case, the algorithm should return 0 because the 0th row contains the most ones, the max ones. Okay? And just as a reminder, in programming, we use zero indexing. So this is row 0, this is row 1, this is row 2, and this is row 3. Okay, and your job is to write an algorithm to solve this problem. All right, so in the first two videos, we looked at inefficient solutions, as mentioned. So just to review what they were, so solution number 1 was to just loop through. So you're given some matrix, and you just loop through each element one at a time, okay? And you just, for each row, you count the number of ones by looping through the whole row. And then you just, obviously, you keep the row with the maximum number of ones you found. Okay, and this is slow because you have to look at every single element. And so that's it. If this is size m by n, this is O of mn. Okay, this is quadratic. Okay, so solution number 2 was to do something a bit more efficient, which is to take advantage of the fact that the rows are sorted. And usually when someone tells you something is sorted, that's a good hint that you should be using that information to speed up your algorithm. Okay, so the second way we looked at was not to count the number of ones, but to simply do a binary search at each row. So just as a review of how a binary search works, so we're given some array. So we're still looking at each row one at a time. But instead of looping through the whole row, we just look at the middle, check out if that's a 1 or a 0, and then say this is a 0, and we know that all the ones must be on this side. So then we look only here, and then we look at the middle again. And then what we're looking for is a 0, 1 pattern. And that's how we find the boundary between the zeros and ones, and thereby finding the number of ones in the row. Okay, so binary search turns out to be log of n instead of linear. So that's a bit better than linear. And so we would say the whole algorithm is m log n. And so my claim is that we can do better than both of these. Okay, so solution number 3. Now, before I get into the actual solution, what I want to say is that, at this point, this might be where you want to stop and try to think of the solution yourself. Okay, because this is what you'll be doing in the coding interview, right? You would be given the hint that maybe you could do better, and then you'd have to think of, okay, how can I do better? Okay, so from this point onward, I'm going to go into the solution. So make sure, if you want to think of the whole solution yourself, please pause the video. Okay, so this is the solution described in words. Okay, and so remember, we're going to take this in steps, starting from the most difficult approach, and then I'm going to give you a little more information and a little more information, and eventually it's just going to get to the answer, at which point you're not thinking of anything yourself. I'm just showing you the solution. Okay, so that being said, here's the solution described in words. Okay, so we're given a matrix, and say we start here. We start on the side where the ones should be. Okay, and so for each row, we're just going to traverse the row until we find a 0. Okay, so say there's a 0 here, there's a 1 here. So we've effectively found the number of 1s in this row. Okay, now let's say we go down to the next row, and there's a 0 there, but there's a 0 there. Doesn't really matter what's here. Why doesn't it matter? Because we know that the row we were just at had more 1s, so we can just ignore this row entirely. Okay, so we go and we skip down to the next row, and say we find a 1 again. Okay, that means there's 1s all the way to the right, and there may be 1s all the way to the left. So we would, again, traverse this row to the left until we find a 0. And that would give us the number of 1s in that row. In fact, we probably don't even need to think of the number of 1s. We're just keeping track of where we are. Okay, so this is where we have ended off, and then we go down again. And so hopefully you understand the pattern here, is we're kind of doing this, this diagonal walk. Okay, something like this. So we go down when we already see a 0 because we don't care about that row because we already found a row with more 1s. And if we see a 1, we go this way because that means there are more 1s to be found in this row, meaning that this row is the best so far. Okay? And so that's the description of the algorithm intuitively in words and pictures. And so given only this, we can actually think of the runtime of this algorithm before we even write any code. And so my claim is that this is O of m plus n. Why? Because we only have to go this way once, and we only have to go this way once in total. Okay, and so this is m, and this is n. So hopefully that makes sense. The number of elements we have to look at is O of m plus n. Now, of course, the challenging part of this is to write up the pseudocode and then the actual code. And so remember that in a coding interview, you're going to have to do that part on your own as well. So if you're watching this video and you would like to pause and try to do that on your own, please do that now. Okay, so I've given you a little bit more information. Well, a lot more actually, because now I've told you exactly how the algorithm works. You should be able to put this into code. Okay, so please practice that. And if you go and you try to do that and you can't do it, then come back to this video and we'll move on to the pseudocode. Okay, so hopefully you gave that a try. And here is the pseudocode for this solution. Okay, so this function, we'll call it linear search. And again, it takes in a matrix A. We don't have to specify the dimensions since we'll assume it's nicely formatted. Okay, so for this algorithm, we're not going to initialize any variable to keep track of the maximum number of 1s. We'll only keep track of the best row. Okay, and that will be initialized to -1. Or as mentioned before, you could also do 0. Okay, and so we'll start by assigning J, which is the column we are looking at. So the column we look at should be the length of, say, the first row -1. And we'll assume that all of the rows have the same number of columns. Okay, so that's the initial column index, all the way at the top right of the matrix. And then we're going to loop through each row from top to bottom, although I suppose it doesn't matter, but this is the simplest way to look through the matrix. Enumerate A. Okay, so that helps us get the index I as well. And then inside this loop, we're going to check this condition while simultaneously walking to the left. So we'll say while J is greater than or equal to 0, so that means we're still within the matrix, and Aij is equal to 1, then walk to the left. So what does walk to the left mean? It just means decrement J. Okay, so minus equals 1. And then if we are doing this, that means the row we are looking at is the best row we found so far because we're finding new ones. Best row equals I. Okay, and then once that loop is done, well, once both loops are done, then we found the best row, and then we can return best row. Okay, and again, you should be able to put this into Python code and make it work. But if you can and you would like to see the notebook, the solution, please go to my website using the link in the description. Or if you're already on my website, then you should be seeing the instructions to get this notebook. Okay, so thanks for listening. I'll see you in the next lecture.